of this and close the session. Highest power of 2 in 100 factorial. So going by that logic, 100 by 2 plus 100 by 2 square plus 100 by 2 cube plus 100 by 2 power 4. Till what is the question? Till the highest power of 2 less than 100. That is two power 6, right? 64. This will give you the highest power of 2. Okay? 50, 100 by, or you can say 50 by 2, right? (25) by 2, 12 by 2, 6 by 2, 3 by 2, 1. So the highest power of 2 75 plus 12, 87, 93, 96, 97. Similarly, highest power of 3 in 100 factorial. 100 by 3 plus 100 by 9 plus 100 by 27, 3 powers, right? Plus 100 by 81. 100 by 3, 33. By 3, 11. By 3, 3. By 3, 1. 44, 47, 48. Similarly, highest power of 5. Highest power of 5, 100 by 5. Highest power of 5, 100 by 5, 100 by 25. Beyond that you can't go because it will be 125, right? (100 by 5), 20, 20 by 5, 4. So 24 is the highest power of 5. What I am trying to do is 100 factorial. If you express it as 5 power 24 into something where this is not divisible by 5, right? Okay. Now interesting one is this 10. Highest power of 10 in 100 factorial. Now it's a combination, if you understand carefully, it's a combination of 10 is a combination of 2 and 5, right? But 2, 3, 5 it is very easy because they are prime numbers. For 10 it is not that easy to do, right? Because 10 is a combination of 2 primes. So you have to split like that. So if you want to find highest power of 10, it has to be minimum of highest power of 2, highest power of 5, right? Because minimum of these will ensure you 10, right? That many number of zeros you will get. So highest power of 2, it is 97, whereas here it is 24. Therefore highest power of 10 is 24. That is how you can try this. Okay. Apart from these concepts, you can as well consider remainder theorem. This is also very important, remainder theorem. What is this remainder theorem about? If f of x is divided by x minus a, the remainder will be f of a. This is the remainder theorem. Okay. So that is x square minus 2x plus 3 if it is divided by x minus 3. You want to know what is the remainder. How do you get that? F of x is equal to x square minus 2x plus 3. Right? So if it is divided by x minus 3, then it is remainder is f of 3. That is 3 square, 9, 2 into 3 plus 3, 9 minus 6 plus 3. You can try this, you should be getting 6 as the answer. How to use this in number system? Find the remainder when (57) is divided by 3. Try this problem. Okay. This 57, let us consider in terms of power of 2, let us say. 57 is 64 minus 7, right? Or 2 power 6 minus 2 cube plus 1. So 57, if you have to express it as f of x, where 3 I would like to express it as 4 minus 1, that is 2 square minus 1. Okay, so x I am taking it as 2 square, right? So this 57, if I express it as 2 square whole power 3 minus 2 square into 2 plus 1, right? So if I have to consider it as f of x, where x is 2 square, I can take it as x cube minus 2x plus 1, where this term is x minus 1. It is 2 square minus 1, right? So if f of x is divided by x minus 1, then the remainder is f of 1, right? So substitute that here. What is f of 1? X cube, 1 cube minus 2x, 2 into 1 plus 1, that is 1 minus 2 plus 1, that is 0. You already know 19 into 3 is 57, right? I am only trying to explain the remainder theorem. We can take much tougher problems than this to get the answer. Please take down fast. Let us take a tougher problem. Try this problem. Okay, 9 power 34 can be expressed as, you can either use remainder theorem or let us try some other method. can be expressed as 7 plus 2 whole power 34, right? Now if it is divided by 7, if I know if it is a multiple of 7, I know the remainder is going to 0, right? So 7 plus 2, now it is like a plus b whole power n, right? I am trying to use this formula. So forget about that coefficient. You will have 7 power 0 into 2 power 34 plus 7 power some number, right? Coefficient C1, I'll say C2, right? I don't need to bother about C1, C2. NC0 is what you get. Okay, NC0, that is 1. So here it is 7 power 1 into 2 power 33, so on 7 power this is C0, NC0, NC0, this is NC34, 34C34, right? I'll write properly. 34C0, 7 power 0 into 2 power 34 plus 34C1 into 7 power 1 into 2 power 33 plus 34C2 into 7 power 2 into 2 power 32, so on. Last term 34C34 into 7 power 34 into 2 power 0. This is 7 multiple, this is 7 multiple, this is also 7 multiple. So from here to here, these are all 7 multiples. So if you divide that, you get 0. So only part left is this. So 34 0, that is 1, 7 power 0, that is 1. So you are talking about 2 power 34, right? So understand? Next time when you want to do like this, you don't need to expand. Simply take this. 2 power 34 when divided by 7, right? 2 power 34, you can as well use remainder theorem here. 2 power 34, I can take it as 2 cube into 11 into 2, right? 2 power, basically 2 power 33 into 2, right? So whereas 7, I can take it as 2 cube minus 1. Okay. So I am talking about x to be 2 cube. So f of x is x power 11 into 2. That is 2x power 11. And x minus a is 2 cube minus 1, where a is equal to 1. So if f of x is divided by x minus 1, remainder is f of 1. So what is f of 1 in this case? F of 1 is equal to 2 into x power 1, that is 2 into x power 11, so 2. So if 9 power 34 is divided by 7, the remainder is 2. That's the answer. Unfortunately, as we can't take doubt session, we'll be closing this class now. Anyway, the number system is done.